So we looked at calls and puts in the last video. That they're not the only options that are out there. There are binary calls and binary puts. The binary part means that its value is either 0 or 1, and again, it's a derivative, so its value is derived from the underlying stock. What it is if the stock is below the exercise price, again, I've chosen an exercise price here of 10. If the stock is below the exercise price, then a binary call is worth 0. If the stock is above the exercise price, then the binary call is worth 1. So it's just 0, and then boom, it's 1. We can also have a binary put, and that works just like you think it works. That's going to be 0 if the stock is below the exercise price. No. That's going to be 1 if the stock is below the exercise price, and 0 if the stock is above the exercise price. So binary options, binary calls, binary puts. So we've got regular calls, regular puts, binary calls, binary puts. We can combine them together. Let's put this back to be a call option. And beside it, I'm going to put a put option. I'm going to put them on the same graph. Okay, so on the same graph, I've graphed in the blue the call and in the red the put. And if I were to buy both a call and a put, those two options added together make a straddle. So sometimes people just call it by its name, the straddle. And I'm adding one call plus one put. So to get the value at expiry, I'm just adding those two values together, whatever the stock price is. When I add them together, well, let's just see what the straddle looks like. We know what it'll look like. It'll look like this V. I'm going to give it its own graph. There's the straddle. So why would I buy a straddle? Well, a straddle makes money, becomes a positive value, has a positive payoff if the stock moves either up from the exercise price or down from the exercise price. So you would buy a straddle if you think that there's going to be some movement in the stock, but you don't know, or you're not sure whether it's up or down, but you know there's going to be some movement. You think there's going to be some news that the company's releasing. You would buy a straddle. So we've got regular calls, regular puts, binary calls, binary puts, and now we're going to start to add, combine options together, like a call and a put is equal to a straddle. Let's get rid of our straddle here. I still got the call and the put, but if I were to, well, instead of a call plus a put, let's just go call minus a put. So I would buy a call and I would short a put. So I'm going to take the call value and minus the put value. When I short the put, that sort of flips the put upside down, multiplies the put by a minus, and I get a straight line that goes through the exercise price of 10. Let's just add the exercise price of 10. So I'm going to take that call minus a put and just add 10 to it. Now I get a straight line of slope 1 that goes through the origin. Essentially, this is equal to if I would have just bought the stock, right? If I graph the stock on the, remember the x-axis is stock, if the y-axis, if I was just graphing stock, that'd be like a y equals x line, I would get this line. So it doesn't look like a slope of 1 because look at the axes are a different scale, but it has a slope of 1, goes through the 0.55. So we can combine, well, essentially, what are we doing here? Let's just blow this up and look at it for a second. Call options minus a put option plus cash is equal to the stock. We could write that any way around. That this is again at expiry. That means that if put options didn't exist, there were only call options. Well, I could buy a call option. I could put $10 and then short a share of stock, and that would equal a put option. So if put options didn't exist, you could make put options by combining stock and a call option. Now, let's get rid of this, and let's look at this relationship here. And let's be a bit more general. That $10 then, that was the exercise price. So this relationship I'm looking at here, that this call minus the put plus the exercise price is equal to the stock, that's, it's more commonly written as call minus the put is equal to the stock minus the exercise price. Now let's make this big because I'm going to be looking at it here. So I'm looking at this equation. Remember, E is just a number. In our case here, it's $10. The call and the put, though, they vary with time. Our graphs that we're drawing here are all at expiry, but the call should be a function of time and a function of the stock price. The put should also be a function of time and the function of the stock price. And the stock is obviously a function of the stock price, but it's also a function of time. As time goes on, the stock goes up, the stock goes down. This relationship, though, will hold at any time. Okay, so we're looking at the call put parity. At capital T, that's at expiry. We've already shown graphically that the call option minus the put option is equal to the stock minus the exercise price. So that's at capital T time. So at expiry, if I were to throw these in here, the call at time expiry minus the put at time expiry minus the stock, again at time expiry, plus the cash. Well, I'm basically moving the stock and the exercise price over to the other side. If I sum up all of these, the sum of this column, so the sum of this portfolio, if you will, the portfolio I build by buying a call, shorting a put, shorting the stock, and throwing in E cash, that sums to 0. So today is sometime before expiry, so I'm using the small t. If I have the call option minus the put option, again different numbers, but they're at today's time, minus the stock and the cash. Oh, I know how much cash this should be worth. If it's worth E at expiry, it's worth less because I'm moving it back in time, so I have to discount it. I'm going to use the so minus R times, so capital T minus little t, that's the time that this E can grow into E. So this amount of cash at the risk-free rate grows into E. So I'm backdating time value of money. So if if at expiry those 4 components of my portfolio sum up to 0, then at any time before that, monotonicity theorem, these 3 sum up to 0. So that means that we wrote this piece down as, at expiry proved graphically, but it works for any time as long as I make that cash amount E dollars, as long as I fix that for time value of money. This equation is our call put parity. So at any time, not just at expiry, at any time, if I know what the call's worth and the stock's worth, I can figure out what the put value is. And we say that this equation is model independent because we made this equation without knowing how to actually calculate what C of T is or what P of T is, what's the call value worth at some time before expiry. We'll get to that. But this works, this equation, we can use this equation before we even know what the model is. It's model independent.